I wanted to introduce the speaker of this afternoon. Mr. Thomas Robinson is the founder of Lever Architecture in 2009. His work explores the link between architectural experience and material innovation. Thinking at the level of construction from the outset allows Robinson to align concept with reality and bringing greater quality to everyday building types. His practice is pioneering the use of cross-laminated timber in the United States with Framework, a project slated to become the first mass timber high-rise in the United States. Other significant completions include student housing for the Pacific Northwest College of Art, campus planning and design for major entertainment companies in Southern California, and a new office development that is the first building in the United States, made from domestically fabricated cross-laminated timber. His firm has been recognized for design excellence by the Architectural League of New York, Engineering News Record, and AIA chapters in Portland, the Northwest region, and Los Angeles. Prior to funding Lever, Robinson led cultural and institutional projects for Allied Works and Herzog and D. Moran. He received his Bachelor of Arts in Architecture from the University of California, Berkeley, and a Master in Architecture with distinction from the Harvard University Graduate School of Design. Please help me in welcoming Mr. Thomas Robinson to speak to you.
Thank you for that introduction, Janaki. I'm incredibly excited to be in Auburn, and as I was walking to the event this morning, I think I had maybe 10 people say hello to me that I'd never met before, just a testament to how friendly the campus is. So I'm going to talk a bit about obviously tall wood, but I also want to talk about the story behind how we became involved in it, because our involvement's really been primarily in the last 3 years. And also kind of frame that up in, how this type of building is relevant not only to our region, but to the entire United States and the world as a whole, and especially regions that where timber is an incredibly important, or maybe the most important kind of part of our economies. I'm based in Portland, Oregon. I don't know how many people here have been to Portland, Oregon, because it's about as far away as you can get and still be in the United States. But that region, Oregon, is the #1 producer of structural wood products in the country, but it's also an amazing place in terms of its nature. This is the Gorge, which is a beautiful sort of part of Oregon at the end of the Columbia River, and a place that's incredibly important to us. And I think maybe I sense from the people that I met here that the landscape and the region is also incredibly important. But this is what that looked like about a month ago. We had an incredibly catastrophic fire that actually it makes me sad to think about, but about 30,000 acres went up of some of the most beautiful landscapes you've ever seen. And I think, as we think about cross-laminated timber and the use of timber, we also have to think about how we can maybe manage our forests in a way that's more sustainable and more effective. And I think that's something that is really important to me personally, and also I think to other people in the room. I want to talk a little bit about the culture of wood construction, because I think what we are kind of involved with, and thank you guys for changing the slides, because they're doing it even without me talking. The culture of wood construction is important because this is we have an amazing history of building with wood where we refined that type of construction to a very high degree. The timber framing was really almost invented in the United States of this particular type in 1832 by George Washington Stowe. So we've been really almost perfecting this type of construction over the last 200 years. So why are we not necessarily be able to compete with it necessarily right off the bat is because we've really refined it. And I think what we're trying to do with, and next slide, with what we're talking about with tall wood today is really learn from our history, but also really surpass it and think of new ways to build. And this is the framework project, which I think Jackie mentioned is the winner of the U.S. Tall Wood Building Competition. It will be located in Portland, Oregon, and downtown. And people ask, well, what is the U.S. Tall Wood Building Competition? It was really a competition funded jointly by the USDA and the Softwood Lumber Board, so a public-private partnership to actually fund the differential research costs to build a high-rise building out of wood that is not in the code. So really the money's not necessarily paying for the building, it's paying for the testing to allow us to build the building. And I'm going to talk about that and then also sort of explain to you how we got there, because I think that's really important. Next slide. If you can click it. One more. So this is, that truck that you just saw there belongs to D.R. Johnson, and they are the manufacturers of the cross-laminated timber panels that form the building that we designed in Portland that is our office. It's a 16,000 square foot building, and what's special about it is not necessarily that it's cross-laminated timber, because there's lots of cross-laminated timber buildings throughout the world. Hundreds. They're just not in the US. But what's special about it is that wood, the wood from this, for this cross-laminated wood came from 3 hours south of Portland. So that truck left, it left a place called Drain, Oregon. Actually, it's Riddle, Oregon, and arrived on our site at around 9 a.m. And by 12:30, we placed 4,000 square feet of floor. So you can kind of get a sense if people understand the speed of that, and then just one more day, we screw it together. And this way of building, the kind of simplest analogy I can say is we're, in a way, building a very large IKEA cabinet. But you think about IKEA cabinets, they're incredibly engineered to the millimeter. So this building's engineered to the 1/8 of an inch once you get off the concrete. So if for contractors in your room, you kind of understand that's an incredibly precise building. And same with an IKEA cabinet, if one of those pieces doesn't fit, you've got a big problem. But if it all fits, it goes together incredibly quickly, and it's, we believe, also economical. It is economical. This was a market rate project. Next, please. So this is the building, 4 stories, about 55 feet high. It's an urban infill project. Next. And this is our office. We're on the top floor, and this is sort of where we work and actually where we're really working and completing all the final testing for the framework project. If you do come out to Portland, there is a great store and a nice bar in the back, so it's always open to the public. Next. So I like this image because for me it combines the things that are really important about this way of building. You're talking about jobs, you're talking about connecting rural economic to development to the explosive growth that we're seeing in our urban centers. So Portland, we have, I think, 30 cranes, and we're a city of 600,000. I think we have more cranes than New York City in terms of what's happening in our city. Seattle has 60 cranes. So just to give you a sense of the kind of explosive growth. And it's also connecting what we live in to the region around us. So all the wood that you see here comes from this range in the distance, 3 hours south. So that's the Cascade Range. Next. So Portland is a city that's really defined by its by nature and by trees. We have the largest urban forest, about 30,000, I think it's 30,000, it's a crazy amount of acres in the city itself, but everything that we build is pretty inconsequential in relation to the mountains and to the landscape. So I think that, and it's also a very young city, next please, and we're very interested in creating value within that city and showing how our buildings actually can connect to that nature. And that's something people really understand. When people come to our building, whether they're contractors or lawyers, almost every one of them has a father or a grandfather that worked with wood in a mill or on a kind of, in a forest. And they immediately connect to that experience. And this is sort of my personal story, which is, I think, indicative of how the country is connected as a whole. This is a house that my great-grandfather built in 1928. But it's located not in Oregon, it's located on Cape Cod. But the funny thing about it is actually all built with Oregon pine. He bought a boxcar of Oregon pine, shipped all the way across the country to the Atlantic, and he had 2 Irish carpenters build this, and you can still see their fingerprints all over there. You can see them there. And so everything in the house is wood. And the experience of this house is really what got me interested in architecture, and I encourage people to think about their own experiences and what motivates them. And until I got to Oregon and started my own practice, actually, I hadn't really built any buildings out of wood. But as you're sort of working on the sort of low end of the architectural supply chain, working with developers, which was amazing, all our buildings at that level are built out of wood, and I'm sure somewhat the same here. Next slide, please. So how do we create great experiences in our buildings? How do we bring architecture to the everyday? And I think this slide, for me, is maybe indicative of our process and how we think about buildings. So we really think that a lot of the products we use are very common products. They're very inexpensive. But what we try to do is, if you kind of think about, it's not necessarily the product itself, but how you transform it. And this is a German artist, and she took like a monoblock chair. There's probably like 2 billion of these things worldwide, and just transformed it into something that is a little bit better. It's a little surprising, and you could argue it's almost beautiful. But I think that's something that we think about when we're thinking about architecture. Next, please. So I'm going to go through a couple projects that sequentially kind of led to where we are today. This is a project that we did called Union Way. It's a 10,000 square foot project. Next, please. And basically what it is 2 lots in urban Portland that we connected back to back, punched a hole through, and created an urban passage that actually creates what's the equivalent of, if you've been to Paris, there's these Parisian passages that sort of run through the city of the 19th century. But really creating that version of a one. And one of the things we wanted to do was think of all the ways we could create that connection, but also connect it to Portland as well. So all the wood that you see here is from a farm, FSC certified farm, outside of Portland on the Columbia Gorge, which I showed you the first image of. And we were able to actually, next slide, we were able to, instead of actually going through our contractor, I remember I actually reached out to the forest owner. Portland's a small place, so find out who owned that piece of land. And we then directly worked with them to actually harvest the amount of wood that was needed. We worked with a mill in Portland to mill it specifically to our specifications with different grades, and then actually had it kind of a contractor to install it. Next, please. And this is the block, the 2 lots, and then next, this is the kind of connection that we did through them. If you're in Portland, if you've ever been there, there's 2 places. We have this amazing bookstore called Pal's Books, so this kind of connects Pal's Books and the Ace Hotel, also from Portland, if you know that hotel chain. Next, please. So just an early image. We did a lot of research on these early passages, and we found out they were originally made out of wood, so that was kind of exciting. And then next. But this is what we were dealing with. 2 nightclubs. Next. And then just some images of how we thought about the light and thinking about how it connected together. Next. And then this is sort of the experience of it today. Next. And that's sort of cutting through the block. Next. If you go back 1, I think, why do I bring this in? Because that experience of the wood is, I think, as important as the technical side, that people respond to it. And actually, 2 of the other projects I'm going to show you just shortly came out of people walking through this space and cold calling us to do other types of projects. So next. So we've done a lot of, my background actually, before I got into having my own practice, I did a lot of work in doing academic projects. I worked on the University of Michigan Museum of Art and a lot of museum projects around the country and the world. But this was our first sort of ground up project, which is a privately owned housing project for the Pacific Northwest College of Art. Next. And you're like, that's a lot of metal. Well, this is actually a wood building. It's what we call 5/1 in the Northwest, where we have 1 floor of concrete and 5 floors of stick frame, which is pretty much as tall as you can pretty much build. And when I got involved with this was like, I wasn't too keen on maybe a wood tall stick frame building. It was a little bit like foreign to me. I'd never done one before. Everything I'd done is in steel and concrete. And through this building, I really learned how fast and how agile and how strong a well-built stick frame structure can be. Next. And we were really interested in this idea of playing with light at every level. Next. And really going back to that idea of understanding your materials. We knew for the budget of this building, which was under $150 a square foot, that we can't do that now in Portland. Maybe you can here. We really started with the end in mind. So we started with the material we knew we could probably afford, which was a metal panel. And this was the metal panel that we built the design around. So kind of going the opposite way, instead of coming up with the design, we said, well, what's the metal panel that we could stomach? Let's build the design around that. And that's really where it came from. Next. So this is sort of how that turned out. And what we like about it, it's a very contemporary building, but it has a lot of depth and a lot of playfulness that these traditional buildings in Portland have and the warehouses have. Next. So this is the plan, just to understanding daylight and how that works, the idea of bringing a gallery at every level on every floor. Next. And then some of the views of the building. We have really tight issues relative to stormwater. We get a lot of rain in Portland. I'm showing you all the sunny pictures of Portland, but it does rain there a lot, so don't get any ideas. It doesn't rain. But we have to treat all our stormwater, mitigate all the stormwater on our buildings on site. So this rain garden is what kind of does that. Next. And you can see in this project, there's really no exposed wood for the deck. And this is next. This is just showing this. Next. And then this is a little different, and it's using wood in a different way. We do a lot of work in Los Angeles for entertainment companies that you've probably heard of. Well, this was a conversion of an existing warehouse for a division of theirs. And this is talking about wood in a different way. Next. Where we're taking a building and reusing it. And next. And we're actually taking, next. We're taking wood and reclaiming it from within LA. So the same distance from this building, say, or from Union Way to the forest, is the distance from this building in Burbank to a high school in Redondo Beach, where we reclaim 10,000 square feet of gym flooring and use it to clad the building. So I think within an urban area, there's also opportunities for kind of reusing wood and actually creating that experience. Next. So that's just the space. That's all actually a gym floor. You wouldn't know it, but it's really part of that experience. Next. And then this is another project, this sort of a project on OHSU's campus. Next, where this is actually the tallest wood building we've built today, which is 85 feet in the back. Next. And you can sort of see it here going up. So it's actually 2 floors of concrete, 85 floors of stick. This is the limit of what you can do with wood. And it's relatively tall. Sometimes when I come back east, I give lectures, people are like, well, do you have experience building wood buildings? Actually, that's all we do. We build a lot with wood, and we know how to do it. Next. So this is just some images of that building and kind of looking at how we can even take the metal system that we did on Art House and convert it into this project, which is also housing for residents on this very large medical campus. Next. Just looking at some of the details, how it works, looking at the fact, one of the things people need to understand about wood is it shrinks and it moves. Stick frame moves quite a bit. This building actually shrinks. We had to design it to shrink 1.5 inches in the first 6 months. So we have to do that also in our cross-laminated timber buildings as well. Next. So this is just how that works and how we deal with the shrinkage in the windows. Next. This is for the architects in the room. Next. Some of the interiors of that building. Next. This is a building that kind of was an outgrowth of the building that you just saw. Next. And it is a wine tasting room an hour outside of Portland, but all the beams that you see there are the same commodity beams that we make by the mile in Southern Oregon to basically supply the headers for all the windows of the those 5-story 501s. Next. So what we did is we worked directly with a manufacturer in Drain, Oregon, where we said, well, can you run a little nicer beam through your system and sand it and do a little higher grade work? So that's really the genesis of this building. And I think the same kind of thing applies for the metal panel I showed you on Art House. This is really that, but just thinking about it from a one element. So this, all the wood in this roof cost, I think it was $17,000. Next. So just some of the inspiration of landscapes and pole barns, things that you're maybe familiar with that we were keen on this project. Next. So there's some views sitting in the vineyard, and it's open to the public, so if you're out in Oregon, go tasting, wine tasting, you can go here. Next. Next. We also were interested, the shape is not necessarily arbitrary, though we want it to be beautiful, but that shape allows us to actually passively cool this building without air conditioning. Next. Next. So, Albina Yard, cross-laminated timber. So this, like I said, is the first market rate building, or first building made with domestically fabricated cross-laminated timber and beams, and also all the connections and connectors were also fabricated in the United States. But one of the things that came up as we were thinking about it, and it was also tied to Union Way, was this idea of forest to frame. And it's really a play on farm to table. So, but those, I think architects should, I find inspiration looking at the culinary movement in Portland, and I think throughout the country, it's not just Portland, where people are looking for foods in their region. They're looking for those materials to create great experiences that are specific to their region. So for us, this building is in a way a kind of reflection, and it's inspired by that. And this is really showing that process. And then the fact that you really should have the trees, at the end of the cycle as well. So you're coming back to the front and around. And that cycle that was talked about in a panel today is really what we're interested in. Next. So one of the things we wanted to do with this building was think about what is the architectural expression of CLT. It's a new material. What can you do with it in a very economical and elegant way? And what you can do with it is you can cantilever in two directions. So with 4 inches of CLT, you can cantilever 4 feet in two directions. It's pretty amazing when you think about it. 1 inch per foot. It's like a 12-to-1 ratio in terms of material and cantilever. And that's really how the kind of facade that you see on the front is expressed. Next. So this is, there you can see it more dramatically how it works. So we're going from a 4-foot cantilever to like almost a 1-foot cantilever, and that's really the undulation that shapes the facade. Next. So next. So how were we able to build this building, which has now been complete for a year? People wonder and ask, and the way we were able to do it was to really start with the supply chain. We knew that D.R. Johnson, after getting a grant through Oregon's sort of new business development group, they had, I think, a $250,000 grant to actually put this press at the end of their line. We knew that we had to organize the design around this press so we could use it as efficiently as possible. They had a capacity of 10 foot by 25 feet, so we designed our building around that module so we wasted as little material as possible. Now, in our framework project, which I'll show you, they can do 37 feet, and that module is also shaping how we're thinking about the construction. So I think in these early stages, that very close connection between the designers and the fabricators is incredibly important. There's a great quote by Leonardo da Vinci that says, think well to the end, begin with the end in mind. And I think we really try to think well to that point, and then if we can't actually get the end result we wanted, we probably need to change our design to actually think of what we can achieve that's powerful. Next. So we have a lot of rains. Basically, it rained the entire time we were assembling the frame of this building. And that's a key factor, and I think we have rain, maybe here there's rot, every sort of issue, insects, you really need to think about not just the material, but how you're going to sort of deal with those issues as well. Next. So just some more images of construction. Next. So this is the end result. That's our conference room. You can kind of see Mount Hood in the right there, just peeking out. It's very frustrating with these photos because it always looks bigger in reality than in the photo. Next. So this is just a view of our conference room. Next. And then this is our back stair. Next. That's Aaron Blake, the owner of the building, for a good friend. Next. And that's the 3-ply material that the building is made out of. Next. This is where all the beams were machined on a Hundiger, which I think when we did this was the largest Hundiger. It's a 5-axis. Next, please. And you just press play. It's a 5-axis joinery machine. So basically what we're doing is cutting a beam, like a 25-foot beam. So we're machining one end of it here. So this thing grabs those beams. They're sort of stacked up like, logs on a truck, and then it rolls one down, grabs it, and machines this end. So these beams have no steel in them. They're all on the columns themselves, or the cross beam. So you can sort of see we're machining this end. They're going to machine this bottom plate, which you'll see in the previous is sort of a white plate. And then this is a cross beam where we're machining the piece where you have a smaller beam that comes into it. And then basically all that machinery turns that thing around and machines the back of the beam and then spits out another one. So this is how we basically manufacture these beams for our building. And this was sort of an unusual kind of, we were lucky that we have a Swiss-trained timber technologist who happens to live in Portland and likes to play with these machines. He actually did the TED stage, if you've seen that it's quite an amazing structure. Next. So we also did a lot of mock-ups. This was one of our failures. We're like, this is too expensive. We didn't, but I think it's very important. It's called architectural practice for a reason, and you should practice before you actually build. Next. So next. This is just showing the joints go together. Next. These were all designed in collaboration with our structural engineer, KPFF. Next. And yeah. Next. And that's sort of the system as it goes together. One of the key things with this system was really thinking about seismic. So there's great systems coming out of Europe, but they don't necessarily deal with the fact, we're in a high seismic zone, and we have much higher loads, and we have drift requirements that we have to meet. So these, I think, are some of the first connections that were really designed with that in mind with the American codes, which are quite strict. Next. And then you can kind of see what it looks like. Kind of a little IKEA-like. Except their stuff probably has better instruction manuals than we do. Next, prettier. You can see sort of that, you see that bottom plate that was machined on there, that rounded one, that's where that is. Next. And then that's sort of our office, what it looks like in place. Next. In the evening. Next. And then this is our little bar in the back, so I encourage you guys to come out there. Next. We actually threw in permitting a couple containers just to make it really hard. So that was exciting little after dessert we put onto this building. So now for something really different. Framework, like I said, it's a building that's not in the code right now, so we really have to think of it kind of in a different light. While Albina Yard was really using what was in the code, at least in Oregon, and we have a pretty, I think, progressive, authority in the state who's really interested in this type of product, and they were really helpful. But what we're doing here is next, is a building where we're having to use that grant money to pay for, fire testing, acoustic testing, seismic testing, fire penetration testing, almost 40 full-scale tests of the various pieces of the building to ensure that it performs like a high-rise. And next, what is the difference between, say, Albina Yard or any 5/1 and framework? The difference is once you get above 85 feet, you kick in a whole other set of requirements for fire and for life safety. And the biggest challenge is that your building has to be able to withstand a 2-hour fire without sprinklers, without collapsing. So so we really, that was obviously a lot. And we actually wanted to go a little farther, and I'll talk about that relative to some of the aspects that we think wood can do even better than other materials, and that's really related to resilient design and seismic. And I always like the most important type on the left, which is what it's made out of, and understanding the fact that we're not even at the capacity of a column or a trunk on a Douglas fir tree, because it's amazing how much they can actually withstand. Next. So when I talk about CLT, I also want to talk about what it's not, and what it's not is cutting down big trees. We in Oregon, it's a relatively young state, still have the kind of cultural memory of these trees you see on our left, and most of our buildings in the city are made out of those trees. Basically, we took these amazing old growth living things and created these amazing living buildings in a way that people covet. But what we're doing next is really the opposite. And I think it was talked about, the nanocellulose technology is really understanding the material character of wood at a very deep level, and using that understanding to actually create massive structures that have, in a way, both the material characteristics of the buildings that I saw you previously in terms of experience, but also some of the inherent fire resistance that those types of buildings have, and I'm going to talk more about that next. And we're putting them together intelligently, and I think the conversation that we're having today between engineering, forestry, architecture, putting all those things together to make a superior product that I think will have a profound impact on the way we build. Next. This is the sort of diagram that I think helped us win the competition on the left, which is really framing what we're doing in terms of rural economic development. Like many states based on timber, there's very much a disparity between, say, what's happening in Portland and what's happening in rural communities in our state. And I think there's a real interest in how we can actually connect both the economic prosperity that you're seeing, in my home to, the entire state as a whole. And I think that not just cross-laminated timber, but the idea of connecting what's happening in terms of the growth to those communities and to those forests is really important. I was in Washington, D.C. yesterday at the Senate office building giving a presentation with the Society of American Foresters, and people were talking about how managed forest, when you have a market, then you have healthy forests. And that's something that we're really excited about in Portland and for Oregon as a whole. I'm also, on a personal level, I've really connected with some of the manufacturers in Southern Oregon that I may never have actually gotten to know had I not been involved in this type of building. And then on the right, this idea of carbon sequestration is a really big issue. It's a really important issue. The idea that, rather than having that wood burn up in a forest fire like you saw early in the presentation, that you can sequester that into a building that can stand for hundreds of years. Next. So what makes Framework special? One, we have a permit to build it. Two, it would be the tallest all-mass timber building in North America. And what that means is that it's really it's a wood core, it's a wood frame. And I'm not saying that that is what you have to do, and there's plenty of examples of other types of buildings, but it was what we wanted to try to accomplish with this building, because it's not just one project that's just for us, but we feel it's a catalyst project for other people. The other kind of key thing, it's the first high-rise of any that we know of that has exposed wood. So one of the tests we're doing, instead of encapsulating the wood in layers of sheetrock or gypsum wallboard, we wanted to have some of that exposed wood because we think that's culturally important, and that's one of the reasons people want to be in these buildings. And then we're the first project to carry out a successful 2-hour basically CLT floor and wall assembly and beam to column assembly in North America, and the first in the world for the entire assembly. So we have people that are interested in our work that are coming from Europe, and I'm actually going to be speaking in Germany at the end of this year. And I think the final thing that's important is that the test will become public. So the idea is that whatever we're doing will be shared with the wider community. Next. So this shows you what I think the part of the building that I'm most excited about, and maybe doesn't get talked about a lot in the press, is an idea of a self-centering, resilient seismic design. And what that is it's basically a post-tension, cross-laminated timber rocking wall system. So I know that's a mouthful, but what it is if you think of my arm as one of those walls you see on the left, it's basically post-tensioned down the center. It's not tied at the base, but allows the building to rock and recenter in a major earthquake. Next. So this is sort of what that looks like in model. These are the nonlinear analysis studies that our engineers have run on these walls. This is highly exaggerated, so we can actually see the movement. Next. And this is how we connect that lateral system of those walls to our gravity frame. We have a series of what I call fuses, what our structural engineer called U-shaped flexural plates. And what they do is they decelerate the building as it rocks, and then the idea is that they can be replaced in a major earthquake. Think of like a spoon. You bend it, it's pretty strong the first bend, and then you bend it a couple times and it breaks. So that resistance is actually keeping the building from moving. Next. But I think as exciting as that is, you need to understand your history. And my daughter goes to a Japanese immersion school in Portland, and we went on exchange in Japan this last year, and I visited this amazing pagoda in Kyoto, and it's actually taller than framework. And it was built in 1450. And what they have in these buildings is they actually have a post-tension system using wood. So that thing you see right there, that's a huge single cypress tree that's tied together and is actually hanging and pulling that entire structure together. So these pagodas, some of them they were saying they were probably like 250 feet tall, and it's just amazing to think that this technology, you're talking thousands of years, 2,000 years. I mean, it's a phenomenal kind of technology, and we can learn from the past, and I think that's why I'm very interested in that history and culture. Next. Now you press the button here. So we're involved with, this is called the Neri Tall Wood Project. This was a test that happened about 3 weeks ago. So we're basically, it's a National Science Foundation grant run by the Colorado School of Mines and a bunch of other collaborators. And next, and press that again, next. And so this is really using our details, and we basically took this thing through 10,000 years of earthquakes in 5 hours. So you can see here, those are the U-shaped flexural plates. This is the post-tensioning here. And then these are the base. So these are small versions. And we're going to be doing a 10-story version of this in San Diego, I think in about 2 years, and then they're going to light it on fire, see how it does. Next. So Framework isn't just a CLT project. It's also has a very interesting client. It's basically a community development bank, and they wanted a building that embodied their goals. A lot of it is related to economic justice and sustainability. So the building's divided up into 3 sections. The bottom is the bank and a public space. The middle 5 floors are creative office or office space for B Corps, and the top 5 floors are affordable housing, which is subsidized by the city because it's very hard to build affordable housing in these areas. So we're interested in how each of those elements can actually contribute, and I think it's important because the program is important. Next. So this is, from us, from an architecture point of view, we want people to really understand this is a wood high-rise. So really understanding, and one of the original inspirations for the architecture was really the idea of an old growth timber where you really sense the size of that, that trunk and then the branches, and then the building kind of opens up at the base. Next. So this would be the sort of main lobby with an exhibit, and then their offices above and a conference room. Next. These are the office floors. Next. And these are the affordable housing floors, very, very efficient studios and 2 bedrooms. And on those floors, we're only exposing the CLT at the ceiling. And I think that was sort of a choice because the floors are lower. We don't necessarily need to have the wood exposed everywhere and pay for that and deal with that. I think it's also important, I'll talk about the fire, that there's a limit to the amount of wood we can expose in a high-rise building where we're having to have the building perform without sprinklers, as opposed to a low-rise where we're using the sprinklers to do that. Next. Just some of the architectural inspiration for the facade itself. And you are from an area with a lot of forests, and this idea that the forest is changing color, and that color is both dependent on the color of the foliage, but also the shape of the leaves, that the building itself responds to that. Next. So some of the details of the facade. And then we're always, as we're getting involved in anything, we always go to full scale, even if it's a very small full scale, to understand the impact of what we're creating. Next. Next. So these are things that I pulled out of our office. These are from last week. So we're basically modeling the entire structure in a thing called Navisworks, where this model, Next, is really the same model that our fabricator's using to do the wood frame. And we have every piece of conduit, every mechanical system, everything that's going into the building is built first in this model. Next. So there's some steel added. You can see the stone piles in the bottom. Next. Those are all the electrical vaults and the major conduits, plumbing. You can see you can see how the housing is up top. Those are all the piping for the bathrooms. Next. And then the framing. Next. The facade. Next. And then we can cut sections and spin this thing around and do clash detection of every little piece in the building, because we need to do that, because we're prefabricating the entire building before we get to the site. Next. Then you could sort of see the walls there. Next. And then you could sort of see some of the systems in the wood. Next. Okay, I'm going to end with some of the testing. Next. So this is the testing that we have done. We've done over 40 full-scale component tests to get our permit, working with the state of Oregon and the city of Portland to show that this building would perform. Next. So this is testing that we did full scale of the, this is basically that rocking wall system put on its side and post-tension. This is at Oregon State University, so it's examples of collaboration between a developer and university. Next. This is, you can press it. Next. What we're doing here is testing the stiffness of the wall and the connectors of the CLT. So we're putting 500 kips it's a 500 kip actuator, which is 500,000 pounds in a space of that at the top there, and then cycling it to make sure that we get the stiffness that's needed. There you go. Next. So we're always testing things to failure. So it really only needs 150,000 pounds, and we're going all the way to 500. And actually, even at that point, it bounced back. Next. So this is the testing of these flexible post-tension joints. Next. So basically, we need to design the building to accommodate 2% drift, and in this building, we're actually able to, we got all the way out to 6% with almost no damage. And you can see, imagine this happening in another material like concrete. Next. This is next testing in Pennsylvania of the floor systems, acoustic testing. Next. This is the fire test we did in San Antonio, Texas. So just, in terms of fire, wood has an inherent fire resistance, even as it burns. So I like the analogy, if you take a big log and you put it on the fire, often that log may self-extinguish. and then you try to light it the next day, and it's almost impossible. That's the char that's actually developing on the wood that actually creates a certain amount of fire resistance. And what we're doing is actually, with our understanding and research that's done actually starting in the 40s and 50s, we understand really well how the wood chars, especially when it's a larger size. Next. So we developed connections and details to actually withstand a 2-hour fire test. And this is really where we ended up, and this is what we'll be building. So what we're doing is taking a small amount of steel and embedding it within a wood structure. Next. And these are the fire test images we did in San Antonio, Texas. Next. 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 Just click it, yeah. So this is the 2-hour fire test. It's not really very exciting, but it's incredibly stressful. So you can see the fire developing in there. That's the beam that you see there. That's the column, and then up here is the CLT. You can start to see it coming through. So this is the kind of testing that we're doing. And I think we did 25 of these of different widths and different species. Next. So this is, just click it. Oh. So this is that coming out after 2 hours. And you can still see it has a lot of capacity left in it. So basically after 3 inches. Next. And I'm going to end with some of the kind of latest stuff that we're working on, and we're exploring, which is mass plywood panels there's a plant being manufactured about an hour and a half south of Oregon. Next image. And what we're doing, we designed an exhibit for a well-known Northwest architect named John Yon, and as part of that exhibit, we got really interested in collaborating with a local manufacturer who was doing this sort of high-tech plywood, because John Yon in the 30s was one of the first contemporary architects to use plywood as a low-cost housing alternative. And they're developing these products, and this is the first structure that we know of its type in the US. But basically what it's doing is they're developing technology, I think, coming out of Europe, but also their own design, where they're basically connecting plywood together like you finger joint timber. So they're creating a kerf joint that creates a structural sheet of plywood that can go up to 50 feet long by joining it together. Next. Click. So this is just a little video. This is of the Freres plant outside of about an hour and a half south of Portland. They go through 5,000 logs a day. This is where they unroll the logs in their plant. So that's one log just going. If you were interested in how why plywood is a pretty efficient way to get wood off a log. And then this is just showing it being manufactured. I'm for sure for some of you this is not that interesting, but I think can understand we were really, this particular material is pretty interesting to us. So what we did is we were trying to create a structure where we only cut those panels, which were their prototype panels, 4 times to create the most amount of space with the fewest number of cuts. So basically, this is that structure being installed at the Portland Art Museum. It took 1 hour with a 100-foot crane to put it together. That truck, they basically loaded those on it. You see the truck in the background where they had the 4 panels, and then they loaded it together. We were really interested in testing the cantilever capabilities of this material. And unfortunately, it's not there anymore, but they've actually moved it back to their mill town in Lyons, Oregon, and I think they jokingly call it like Frere's Henge now. So it's great that town is excited about it. It's great that you guys are excited about it as well. It's just another view. These are 4 cantilever panels. Next. And I thank you for the opportunity to share our work with you, and I hope we have time for some questions.
We're going to have 2 mics on either side of this auditorium. So if you have any questions, please move to those 2 microphones and shoot any questions if you have to Mr. Robinson.
Transportable, do you see that becoming if you were to move that
I think it is transportable. I mean, I think we're really working with the, ICC, International Code Committee, and, we're not trying to do something that hasn't been reviewed. I think it's also, but I think it's like any new thing, it requires an open mind. It requires people to kind of be interested and willing to work with you to try something a little bit different. So I think it's really those two things. But I mean, our goal, I think, is to create some models that people can use. But I also, also the warning is like, you can't just take, the details from one place and transpose them the other, because there's every place is different, every place has its specific issues. I mean, I was just talking with here, it's like in the South, I might want to have a concrete first floor, and then go up from there. So, or have some kind of more protection from the earth for the wood. So I just think you have to really think about not just the code, but really the issues that are specific to your region. Any other questions?
Hi. Do you guys ever think about doing LEED or any of the other sustainable challenges for your buildings? Because you've got wood, so that's really sustainable building material itself. So do you guys have a with that? Or
Yeah, I mean, almost all our other projects are LEED certified, so I didn't really talk about that. And this one, the framework is not, and that's partially, we may end up doing it, it's partially because you don't, the current way LEED and some of these programs are structured, you don't really get the credit for what you're doing at the kind of, what I almost call like the bones of the building, as opposed to the efficiency of the mechanical systems that you add on after you've maybe built a building out of concrete. Or other types of materials. So it's not to say either one is bad. We do concrete buildings. I'm not somebody that says we don't do them, because they have their place. But in this case, it's like what we're doing. I think with these wood buildings, I think what's important is how the wood is being sourced, and the idea of the management of the forest itself. In Oregon, we have the Oregon Forests Act. So if you're required when you log timberlands to replant that land. That's one of the sort of base things, and then you can go up there to SFI and FSC and different levels of sort of management certification. So in framework, we're biting off a lot on this one, so we're like, well, maybe we don't need to bite off LEED just yet, but on our new projects, we're looking really carefully at how the wood is sourced and managed in the forest. Any other questions?
Hey.
Oh, yeah.
Something I was kind of curious about is it appears that this material could be a replacement for steel beams. And when you look at the history of steel beams, a big concern is the framework to sort of square footage ratio. And I'm wondering if there's any significant trade-offs on square footage for using this material instead of steel beams.
I don't really see it as a replacement for steel. I see it more working in concert with steel, because steel is, I think, I don't think we can't span as far with wood alone as you can span with steel. But what we can do, and there's some great work being done in Vancouver, BC. I was up there giving a lecture, and one of they had a contractor who built the speed skating oval at Vancouver, BC for the Olympics there, talk about the hybrid structures that they were building, combining steel and wood, that could span even farther, because wood has an incredibly high strength to weight ratio, but at a certain point you need the strength of steel, say in tension, to actually create these strong structures. So I don't really see it in either or. I really see it as like anything. You build a steel building and you have concrete decks. You might have steel columns and wood decks, or you might have wood decks, concrete, and concrete fill on the top. So I think there's going to be more. I think you're going to see more hybrid types of construction. So that's I think where it will go. Hopefully that answers the question.
Yes, thank you.
And if people are afraid to come to the mic, you can just ask the question from your seat if you want to. I think we're good. Oh, is there one there?
I see you're using steel joints.
Yes.
Have you ever thought about using also wood joints?
Yeah, I mean, I think the issue is oh, yeah, I'll repeat the question. He was asking, he said, we're using steel joints. Have we thought about using wood joints? And I think at a certain point, the kind of capacities that we're dealing with, steel is just incredibly efficient, and strong. So there's a lot of sense in that. But wood to wood is, I think you'll see more of that. It's just when we're getting into seismic loads and things like that. I could see like in a place here where you don't have the seismic load, you're just dealing with gravity loads, just wood bearing on end grain is quite good. I mean, I think in some other projects I've seen where they just add a steel, actually some of the details on framework, we're literally adding a steel plate and then just using that to bear, and so the wood doesn't crush. But there's, that's even more economical, in a way. So I totally think that's an interesting approach. You have a?
My question actually kind of builds on his question. Going from steel to wood in those joints and the fire codes and having that exposed.
Yeah.
How does that work with your detailing? Do you have any kind of special things that you have to do when you have those exposed?
I don't think we have a half an hour, but I mean, just high level, yeah, everything you just said, you just have to, I think the thing I can add is what is needed to do those types of connections is you need, at least we did on framework, we needed a fire engineer, we needed a structural engineer, we needed the architect, and we needed the fabricator installer all working together at the same time. So you could come up with a cool detail that works structurally, and then it's too expensive to fabricate, and then it doesn't work in a fire, and then it looks really terrible. And then you're kind of back at ground zero. Is back there?
From my really limited knowledge of CLT, I sort of expected to see really big walls with computer cutouts for windows and things like that, instead of a more traditional structure with facade unlike. Is that a limitation on the technology or just design?
I think, we're saying you kind of got to walk before you can run a little bit, so we're really kind of taking a little bit baby steps. But I also think that simple is good, and I think that, like on our office building, for those construction probably noticed that really only the columns and the diaphragm, the floor plates are mass timber, and the rest is stick frame walls at the perimeter. I think it's an office building, so we want larger spans and bigger open spaces and more flexibility. So having a bunch of CLT walls that are maybe harder to run things through, that's more money. So that's why I mean the hybrid kind of approach is important. But you will see more of that kind of construction where you have the walls and everything cut into it. But a lot of those seem not to actually happen because it's really expensive. Time on the machine is really expensive. So what we did from, say, the project you saw for Albina Yard, the connection looked pretty complicated, right? When we got to framework, we tried to simplify it to do as little cutting as possible on the beams. And I think if you look at the evolution of, say, structural systems, say how people put together steel beams in the 1970s, to say how they do it today. They're always looking for that kind of efficiency, to make it a little simpler. And I think that's probably a good contribution that I think the United States can do to this type of construction, is thinking about how to make it incredibly efficient. And then I think you'll see your wider adoption. Does that answer your question? Okay. Anyone else?
So you talked about Oregon's kind of specific resource profile, how it lends itself to this kind of building. So I think for a lot of the folks in this room, they see an immediate connection, immediate sort of parallel with Alabama.
Yeah.
Similar kind of resource profile, so it's exciting to think that we can have a similar kind of output, similar sort of beautiful building. But my question is kind of thinking ahead. The other side of that coin, is that resource profile, is that required to do this kind of building? Could, in the future, say, the interior of the country, where there isn't the same kind of forestry, or other parts of the world, maybe the Caribbean, could they
Yeah, I think it's already happening. It's just not happening in the U.S. I mean, there's 14 manufacturers of CLT in Europe, and they export all over the world, to Asia, to Australia, to London. There's 300 buildings out of CLT in London. There were like none 10 years ago. All those buildings were fabricated in Austria and shipped to London. And now they're actually building I think a 1 million square foot fabrication facility in the south of London, in the countryside, to actually both assemble housing and potentially manufacture it there. So it's already happening on a major scale. We're just not doing it here. I mean, I think so. I think for us, it's like looking at the examples of what you're seeing happening, and seeing where we can maybe adapt or improve or contribute, relative, say in Portland, maybe what we're doing that's new is the stuff with the exposed wood and the fire, and this sort of idea of a resilient, repairable building at a large scale. Maybe here in Auburn, it's like, well, how do you build these buildings in maybe a more, quote, tropical environment, where you have things like that nature, or you're working with southern pine and that type of thing. So I don't think it's a question of if, it's who and how. On the back.
Why would you say it's taken the U.S. so long to adapt to the CLT? Is it just something as simple as code, or does it also involve like the culture?
I think we're just such a big country, and I think that people were doing fine, so there was like saying no need to really change. I think, Europe is a collection of smaller countries competing against each other, and so I think that people are sort of trying to figure out, well, what's the next new thing so I can remain competitive in that environment. So I think that's part of it. Part of it, I think, is just risk, fear, if you're out in front, that, you'll get sued or something will go wrong, so I think that is definitely a limiting factor here. But I do think, that there's also, if you're looking at the history and looking at what's been done elsewhere, you can learn and maybe do a little bit better. I like I don't know if you guys know the chef like Danny Myers, who does he owns Shake Shack and stuff like that, but he makes like a little bit better hamburger and a little bit better shake, and he's like killing it. So so to me, it's like, how can we kind of do incremental improvements on what we're doing to make better experiences? And I think that we're already trying to do that. And we have a lot of Europeans come and see our building and our office, and they're really impressed. They're like, wow, it's Doug fir. They don't see Doug fir as like that kind of building. They have spruce. So I do think, I'm excited about that and collaborating with whoever's involved in it. Time maybe for one more question, or we're good? Oh, one there.
Right, so the wood is heavily engineered. Is there almost no risk with insects or
He was asking if with the wood that's engineered, is there no risk with insects? And I think there is risk. So I think some of the, we talked about the nano technologies and coatings, and I think those go hand in hand with using these materials in different environments. So yeah, I think there's risk, so you have to really deal with it. But it's the same risk that you have on all the wood buildings that you build here. So it's not like there isn't technologies of treatment that you use. It's not like all the buildings in Alabama are falling down, right? They're wood, and they're that people know how to kind of handle that. It just requires that expertise. Well, thank you guys, and yeah, take care.
Well, thank you, Mr. Robinson, as a token of our appreciation of your presence here and for giving an excellent talk. Auburn University would like to present you with an eagle. This eagle has got a special meaning. Okay. Probably anywhere you go in the world, and if you shout "War Eagle," probably you will hear back.
Thank you. I guess, Guard Eagle.